Alright, here are a few more examples from the worksheet that we did today. To start off, I'm going to do HCN. So again, all of these problems should be worked by using the supply and demand method. The first step is to simply write down the names of the atoms that are present within the compound. We have a hydrogen, carbon, and nitrogen. We then need to take into account how many of each atom are present. In this case, there's one of each. We will now set up what's known as our supply column. Now, with the supply column, again, we're just looking at the valence electrons that each atom contributes. So hydrogen, because it's in the first group on the periodic table, first group, will supply one valence electron. And since there's one hydrogen, that'll be multiplied by 1 for a total of 1 valence electron. Carbon, being in group 14, will supply 4 valence electrons. That's times 1 carbon, which is 4. Nitrogen will supply 5 valence electrons, times 1 atom of nitrogen, which will be 5. When we add these together, this will be the total amount of valence electrons that our atoms have supplied in order to be able to make the molecule. Now, let's look at demand. Demand is based on the octet rule, in which most atoms want to bond so that they can achieve an octet of electrons. Except hydrogen is one of the exceptions, and it only demands 2 electrons for a full shell. So we'll have 2 times 1 hydrogen is 2. Carbon follows the octet rule, times 1 carbon is 8. Nitrogen likewise follows the octet rule, which is 8. Let's add these together. We get 18. Now, since our atoms are demanding more electrons than they supply, that means that we're going to have to share some electrons. So in order to figure out how many electrons have to be shared, we'll take our demanded electrons minus the electrons that we can supply, and that will tell us the number of electrons that must be shared. Now, because we know that atoms share electrons in bonds, and each bond has 2 electrons, we're going to divide by 2 to see how many bonds we should make. So, in this case, we need to make 4 bonds. Now, here's how we actually take that information and apply it to drawing a Lewis structure. So, going back to our rules, since our compound has carbon, we're going to use carbon as the central atom. Okay? Then I'm just going to place hydrogen on one side and nitrogen on the other. Okay. Now, I have 4 bonds to use, and we know that our 4 bonds always have to start from the central atom. But let's keep in mind that there's a rule that says, or kind of a principle, that hydrogen and halogens, that's things in group 17, for our purposes, they're only going to be able to form 1 bond. So we know that this, from hydrogen to carbon, can only have 1 bond. So we've used one of our bonds, so that means the remaining 3 have to be placed between carbon and nitrogen as a triple bond. Okay, now let's take into account how many electrons we've used in the bonds, and then how many electrons are remaining. So with 4 bonds, each with 2 electrons, that means that so far we've used 8 electrons. Okay? Now we started out with 10, so that means we have 2 more electrons left that we need to place. So the way we determine where the electrons are placed is by looking at the atoms to see which atoms still need a full octet. Now keep in mind, shared atom or shared electrons count toward an atom's octet. So for example, we know that hydrogen is satisfied by 2 electrons. It's sharing these 2 with carbon, so that counts for hydrogen. Carbon wants 8, so it has 2 in this bond, 2 in this bond, 2 here and 2 here for a total of 8. But now when we check nitrogen, we see it only has 2, 4, 6 electrons. So our remaining 2 electrons should be paired on nitrogen. And whenever we have a pair of electrons isolated on one atom, that's known as a lone pair. Alright, so this should be our Lewis structure for HCN. Now let's move on and do another example of CO3 2-. Okay. So, first of all, just like we would with the supply and demand method, let's list out the atoms that we have. We have 1 carbon and 3 oxygens. In the supply column, we'll take into account the valence electrons. Carbon supplies 4 valence electrons, times 1 is 4. Each oxygen will supply 6 valence electrons, times 3 is 18. Let's add that up and we see we get a total of 22 electrons. However, we also have to take into account that since our molecule has a charge of 2-, that means that 2 extra electrons have been added. So our supply of electrons is actually 24. So now let's move on and do the demand column. Carbon and oxygen both abide by the octet rule. There's 1 carbon and 3 oxygens. Okay. So let's add these together for a total of 32 demanded electrons. Again, since the atoms are demanding more electrons than they can actually supply, we're going to have to share some. So let's take the demanded minus the supplied, and that will get us the number of electrons that have to be shared, which in this case is 8 electrons. Since each bond contains 2 electrons, we divide by 2 to figure out the number of bonds. In this case is 4. So again, because our compound contains carbon, we're going to place it in the center. Okay. Now we're going to put oxygens around it. Okay. So now, since we have 4 bonds, let's start by just making a single bond to each oxygen. Okay, so we've used 3 of them, but now what about the 4th one? Should I place it here, or here, or here? Well, we see, either way, since this molecule is kind of symmetrical, it doesn't really matter where we place it. But since there's more than one possible Lewis structure, we know that we're going to have to draw resonance structures. So let's just draw the first one, then we'll talk about what it looks like otherwise. So if we place the double bond here, now let's go in and fill in our remaining valence electrons. So far we've used 2, 4, 6, 8 electrons in our bond, but we had 24. So now let's go through and see which of our atoms need to complete their octet. Here, this oxygen only has 2, 4 electrons, so it needs 4 more. 1, 2, 3, 4. This oxygen here only has 2 electrons, so it needs 6 more. 1, 2, 3, 4, 5, 6. Carbon's good. It has 2, 4, 6, 8. And this oxygen over here, it only has 2, so it likewise needs 6 more electrons to complete an octet of 8. Alright, now if we were just drawing this one structure, since it is an ion, we would put it in brackets and then write the charge around it. Okay? But since this is a resonance structure with more than one possible way to write the Lewis structure, we'll need to also draw the additional structures as well. Now let me erase so we can have a little more room. Alright, so I'm just going to draw my double-headed arrow and draw the next resonance structures. So basically I'm just kind of swapping the double bond around the atom. And so in resonance structures, the position of the atom doesn't change. We're just kind of changing around where the electrons are. So notice the carbons and oxygens are all staying in the same place. Alright, and there you have it. Those are the resonance structures. So I hope those extra examples were helpful to you all.